Hello guys, and here it is, Genius File Studios with another video. Today we'll be talking about gravity. And gravity is a really main portion to our universe. Like we have gravity has done so much to our universe. It has shaped our universe, has made our universe into something more mature in a way of the universe. So today we'll be talking about gravity. As you can see here, this on the right, you can see this huge little cloud of just dust, different compounds of dust, like hydrogen, helium, nitrogen, whatever element you can name is in this nebula right here. And then this nebula turns into this right here, this galaxy. So this how does this nebula, which is just a cloud, how does this mature and become into a galaxy like this? Have you ever wondered about that? About how this galaxy turned into something so mature like this? Well, it's all about gravity right now. This is all gravity, and it's really gravity has been shaping our universe, has been kind of like the mother of our universe, has been making our universe into what it is right now. Without gravity, our whole universe would just be floating everywhere, crashing together. There would be no such thing called galaxies. There would be no such thing called us. All there would be is just random atoms flying everywhere. There won't even be a nebula. Even nebulas are shaped by gravity. There wouldn't even be this. There would just be nothing. Just be a whole bunch of atoms jiggling and going a billion miles per hour. So, now we'll talk about how this gravity works, or the mother of our universe. Gravity, or we could say general real relativity in this way, looks something like this. This is a small diagram. Imagine that you were to keep a blanket. So let's say like there's a blanket right here, and then you hold the blanket on this side. You hold the blanket, and from the other side, another person holds it, or your friend, let's just say. And then both of you guys pull the blanket. Let's say you guys want the blanket a lot, so you guys are pulling it really hard. So if you pull like a blanket really hard, what happens? It becomes super tight, like a tight paper. And then if you were to drop a tennis ball in it, now let's change perspective and let's say this line over here is a blanket. If you were to draw a tennis ball in it, it would turn, it would curve like this, and your tennis ball would be sitting in the bottom like that. It's the exact same thing what gravity does. So if you were to keep a whole, like another diagram, so let's say you had a whole bunch of atoms here. So this atom has some type of a mass, has some type of weight, has some type of shape. So with all this shape, all of this falls together on the gravity net, which is a visual made by scientists, and it makes a dent. And because all of it is so close and compacted together, it creates another huge molecule. So it creates a molecule. And then now this molecule has some gravity, like this. And let's say we come back to the example with you and your friend pulling the blanket. Let's say you were to drop a ping pong ball on the side. The ping pong ball, if you were to keep it on the side of the slope, what do you think will happen? Pause the video and think about it for a while. Well, obviously, the ping pong ball will slip down the slope and hit the tennis ball, just like that. Like it's a really common sense idea. That's exactly what you can see over here in this picture on the left. That's exactly what happens here. If there another molecule just came over here, we wouldn't be like the ping pong ball that would just be sitting on top of the slope and fall down. What would happen? Let me get some space. You already understand this. What would happen is that both the gravity from your first atom, um, wait a second. the gravity from your first atom and the second atom would make two different dents because both of them have their own gravity. So both of them would have their own gravity, and then this thing would be a little slopey in the middle, and then both of these atoms will collide. Both of these molecules will collide, and creating an object with two molecules in it. And now this will have even a deeper dent because now there is more mass or more weight to put more weight on the blanket. So that's exactly how gravity works. So this is how gravity works. Overall, gravity works like a heavy ball on a really tight blanket. If you were to keep the ball on the blanket, it would make a dent. And if you were to make a ping pong ball roll on it, it would make the ping pong ball will roll into the tennis ball. So if that doesn't make sense, then rewind the video, or in the comment section, you can look at the article, and there's some more description over there. So this is technically how gravity works. And now back to the part where we were talking um about like the nebulas and gravity. This is exactly how nebulas um mature and become into a galaxy. What happens is atoms the atoms come together and just keep on colliding and colliding, making dents and more just keep on coming together until there's such a huge, because there's so many billions and trillions and quadrillions and infinity, so many atoms in this that there's so much of mass that what happens is that there's a super duper 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 deep dent. I can't even draw the dent. Wait, let me draw it here. If this were the gravity net right here, if this were like the kind of the sea level gravity, dent would be so deep like that. And this is exactly how a black hole forms. It's a dark excuse me. It'll be a really dark it's really dark because it's so deep dent. And this dent is a black hole. So because light is made out of photons, and photons has some mass, because it's so deep and it's so wide. I'm unable to draw the wideness here, but in real life it would be really wide as well. Because of its wideness and its depth, light does not have enough kinetic energy to go from side A to side B, so it falls in. So that's how light cannot escape the black hole. So that's how a black hole works, and that's how gravity works as well. Over here, okay, and so that's exactly what general relativity is what it's called. It's a small branch of gravity. So that is how general relativity or gravity works. And now this is a more detailed drawing of something which is more likely to happen in the real world in astronomy. So as you can see here, there's this one galaxy on this side over here, okay? And there's this another galaxy right here. So because of these dents, each of the gravitational pull, both their gravitational pull is bring them both together. And this creates an ultra huge galaxy. So even though after being super matured and more likely to look like what the universe is today, general relativity is still making our universe more and more mature and making it more look like what the universe should look like. And if you looked at one of my other videos I made about scaling the universe, you saw that um, the Andromeda galaxy and the Milky Way galaxy will collide. So their thing is something similar to like this. Like their gravitational pull is moving it slowly together until when it's so close that it just has to go at a faster rate and then it'll collide. So this is pretty much similar to what I talked about in that. And now this is another drawing which will help. it also works in smaller objects. If not galaxies, it can also work in our solar system. So our Earth it is really, really, really heavy, but not as heavy as the Milky Way galaxy. But still, it has some mass. So this mass over here has makes it have its own gravitational pull, and then this gravitational pull keeps the satellite over here, it keeps this satellite in the Earth's gravity and make sure it does not just zoom out everywhere. And because of the Earth's rotation, like you can see these little curved lines, it kind of works like a hurricane. So it sweeps around in it sweeps around in a circle like this. The gravity sweeps around in a circle like that. And when it sweeps around like this, that's how some type of spiral galaxies form. And that's how like stuff from really far away, like I said, there's an asteroid here. That's how asteroids come, and that's how like asteroids, they like first orbit around a little, and then they collide into the Earth, like small asteroids. And like most of you guys must know this, but uh like about almost every day, hundreds and hundreds of small asteroids hit Earth. So this is how this really, really small asteroids come to our Earth in this similar pattern. So as you can see, our Milky Way galaxy and our whole universe works in the way of gravity. Gravity is the mother and father of our universe and has helped our universe to mature year by year, century by century, and billion year by billion year, and is still continuing to mature our universe. Thank you for watching, and please press the like button and subscribe. Thank you for watching Genius File Studios Gravity.